This is the High Performance HVAC podcast from National Comfort Institute. This podcast was recorded live at the AHR Expo 2025.
Hey everyone, David Richardson here with National Comfort Institute. I am fortunate enough to be sitting here with a couple of animals when it comes to heat pump retrofits, which is what we're going to chat about today. I'm going to start off going to my left, have everyone introduce themselves and tell us a little bit about yourself and what your experience with heat pumps are.
I'm Ty Branaman, been in the field since 1995, and I'm a lifelong student of HVAC. There's always something else to learn, always something new to learn.
All right.
I'm Ben Lipscomb with National Comfort Institute, Director of Engineering, and I've been messing with heat pumps for, 20 years, I guess.
Yeah, and you're from Montana too, so
I am.
Totally different climates up here.
That's right.
I am Adam Mufich with NCI, and I am a trainer. I also work on the curriculum side, and I've been actually taking systems and going all electric in Chicago for a good handful of years now, when other people say it's not possible to do.
Yeah, there's some myths about putting heat pumps in colder climates. And Adam, you're actually working on a class about that right now. It's your first class with National Comfort Institute. You care to chat about it a little bit? Tell us a little bit about it.
Sure. Yeah, this is top secret, so we're not allowed to talk about this. So don't tell anybody. All right, but it's the whole idea behind the class is I kind of followed my process, right? And just to give you an idea, most of the customers that I had that switched over to heat pumps, they called me because they called 2, 3, 4 other contractors, and they said they just can't have it. You had to go dual fuel, right? Now the class is not specifically about going all electric, but it's about looking at a process and kind of, identifying issues with a house and the HVAC system as a whole, and trying to overcome them and design for it, right?
Right. One of the things I loved is your heart and soul's in this class, and it's instead of it being a random string of facts, it's actually a process and how to do this and be successful without inheriting everybody else's poor craftsmanship. So, all of us right now, we've had experience with heat pumps. Heat pumps have been around a while. Ty, what was your first experience with a heat pump?
Well, I used to hate heat pumps. Back in my day, we had the actual time clock, we had the ice cube relays that had wires jumping everywhere, and honestly, at the time, I didn't fully understand electrical like I should have, so just easier to blame the equipment. And I was complaining about heat pumps and how evil they were to a man, and he says, well, that's interesting, because I work on walk-in freezers, and it's 100 and something degrees outside, and I have the freezer that's well below zero, and we move heat, and that's exactly what a heat pump does. He goes, so how about you go find the facts about your reasons for hating heat pumps and then come back to me and talk about it? And I'm like, you got it. And I went and researched and studied. And at that time, it was before Google. So we actually had, printed books and paper. And I searched and searched and I could not find anything. But the more I learned, the more I realized how simple they were. And then once I learned heat pumps, it was so much easier working on them. I was able to solve problems that nobody else could. And I ended up being the heat pump specialist. So just by simply learning.
Cool. Ben, I know you got a lot of experience with heat pumps. What was your first run-in with one?
Let's see. I would say when I was in high school, I went to work in this lab at a university, an HVAC lab, and, ran into a heat pump right away. I didn't have any HVAC experience at all, but I learned about this machine that could, move more heat than the energy that you were putting in, and it kind of blew my mind, and just been fascinated ever since with everything HVAC. So.
Nice. A lot of experience. Now, Adam, we know you've got a lot of experience. I guess the question here is, do you walk the talk? Do you have a heat pump in your own home?
I do.
Why don't you tell us a little bit about that experience?
That was definitely like a learning curve, right? And it was a long drawn out thing. I have an 1,800 square foot ranch, just 1960s ranch in the Chicagoland area, and it was very leaky when I started off. And I actually had a 100,000 BTU furnace and a 3-ton condenser when prior to the heat pump, and I wanted something that was more efficient. And actually, when I had homeowners and customers calling in and saying, "Hey, I want a heat pump." I wasn't sure how they were going to feel if they removed a gas system, right? And I kind of wanted to experience it before selling it to people. That was the reason why I went all electric. I don't mind gas. Gas is fine, but like I just wanted to sell somebody something that I was familiar with. So that's why I started going down that process, and I started tightening up my home, using a blower door, redesigning the duct system, make sure I had a tight duct system, and I went from there. And it works fine. I can maintain 70 degrees at negative 15 outside, no problem.
You've got a session coming up tomorrow too, because you mentioned a very interesting intersection, and that's where the HVAC and building science sides intersect. And just to give a plug for your session, because I think you do a masterful job explaining why, if you're a HVAC professional, why you should even care and how to get into it. Just some very simple steps. You know, we know heat pumps, everybody's talking about them. They're on the lips of our industry. What do you guys think is probably one of the biggest obstacles that our industry has to overcome with heat pumps? And you guys, I'll let you choose who goes first.
Well, it comes down to education. The same problems that were preventing me from learning back all those years ago are the same problem today. So you got the mindset of, hey, I don't understand this. And typically humans dislike things they don't understand throughout history. So first off is people just don't understand what's happening. And then the second thing is not looking at the house as a system. So they're looking at it as this appliance. And as well, it's easier to fix this appliance than this appliance. But we look at the whole house as a system. And when I'm finding that people that promote gas furnaces aren't doing them correctly either. They're oversized, they're leaking, they're having carbon monoxide issues, they don't know combustion analysis. So unfortunately, gas furnaces, quote unquote, work, but they're not working correctly, and it's an actual hazard. Whereas heat pumps, when they don't work, at least you're not going to poison the family. And so ever since I've learned from you, Dave Richardson, that I keep my carbon monoxide monitor with me at all times, and that's one of the solutions I like. It's technology for me. Gas furnaces love them, heat pumps love them, but at least if a heat pump malfunctions, it's not going to take out the family. And so that's one of my viewpoints. But it just comes down to education, learning, and looking at that whole house as a system.
Perfect. What do you guys think?
Yeah, I think those are great points. I think that perception of heat pumps from people that have maybe had them in the past or like heard about them in the past and things like that. Older heat pumps that didn't work as well, especially in colder weather. I think that's something we have to overcome. But then out there, putting in the new ones, there's still traps that people can fall into. And I think one of the biggest ones is system sizing and selection. Adam mentioned that in his house, he had a 100,000 BTU boiler and a 3-ton air conditioner. Well, does that mean I have to put in a 7 tons worth of heat pumps into that house to keep it warm? No, that furnace was oversized in the first place, and we just have to teach people how to, go through, do the right sizing, figure out what heat pump is going to work, and I think they'll be happy. The customers will be happy with that, but I think that's an obstacle.
Well, even those older ones that we complain about that didn't work as well, most of them were just installed incorrectly. I mean, they didn't pull a good vacuum at the beginning. They didn't have the proper piping on them. They didn't have the proper, number one, airflow. And if you don't have the proper airflow, you're going to have issues. And then duct leakage, house leakage, the drafts. So I think even with the early ones, it was just an issue with bad installation. And people just don't know. They don't know what they don't know. So they just install things the way that somebody else told them to, and they don't know. And that same problem, I'm afraid that we're going to see in the heat pump movement is you get people installing heat pumps incorrectly. All the technology in the world can't solve a bad installation.
There's a mentality of just wanting to swap boxes with this and then check boxes saying, hey, I installed a heat pump. I'm doing a great job. And as you guys are mentioning, you may miss some things. I know something that was very common for us to encounter was someone to pull a old, Ben, you mentioned, a large furnace, pulling that old furnace out that may have had a 70 to 100 degree temperature rise out that was installed on a bare metal duct system in a crawl space, and then put a heat pump in it and not touch the ducts, and then wonder why it runs nonstop. The electric bills are through the roof, and it won't maintain comfortable conditions. The old ducts, if you're blowing 175 degree air into them on an old belt driven furnace, and now you've got a heat pump which if you're lucky, you're getting 100 degrees on a really cold day, and it just doesn't weigh out.
Yeah.
So, Adam, what were some of the biggest obstacles that you had, even convincing your customers to look at? Because there's a perception.
Yeah, so I want to circle back to the class, if you don't mind. Can I talk
Please,
about a little
please.
detail about the class? So most technical training, I think, is very focused on like a subject matter. Like, hey, we're talking about heat pumps. This is superheat. This is subcooling. This is hot gas. Whatever, right? Very early on in the class, I have a section that we talk. It's customer discussion, right? And I think that was kind of like laid the groundwork for the class, because like my whole thought is you need to figure out why the homeowner wants a heat pump installed, and you need to see what are their goals, and you start kind of if they're looking to go all electric, or if they want to go super energy efficient, there are different paths that you need to follow to get them to their point, right? And you can't just glaze over important details and think you're going to have a solid outcome at the end of the day. So, yeah.
Excellent point. If you guys had to sum up, because there are problems with heat pumps. I mean, I think we'd be naive not to mention them. If you guys had to summarize what you feel is the number one reoccurring problem with the heat pump, what would you say that is? If you could clarify it like that or classify it.
Airflow. Number one, airflow, absolutely without a doubt.
Airflow, they're not getting it right. Adam, what would you think?
Mine kind of goes. It's kind of two in one, but sizing and equipment selection. Like I think that's huge. It's not all heat pumps are created equal, right? So you could have 2 3-ton heat pumps or 2 2-ton heat pumps, and they do completely different things.
So for those who may be familiar, how do you go about figuring out if you've got the right heat pump or not? Where do you start? If someone is listening to this and they're brand new and they're like, well, where do I find out about that? How do I know if a heat pump's the right size?
So, the key is to start with a load calculation on the house. So, a manual J, and that'll tell you what your heating load is at those design conditions. Then you have to go up and look up that equipment's performance under those design conditions and, see if it's even capable of producing what you need in that home.
And if it won't, what do you do?
Well, if it won't, then, obviously the best thing to do would be to go and select a different piece of equipment that will meet those requirements, or you can make up the difference with, some auxiliary heat or whatever you need to be able to fix that system.
So in a market that maybe gas is cheaper than electric, this is where it would probably make sense to go with the dual fuel option then.
Absolutely. And that can all be figured out too, right? And it is overwhelming. All right. The first time I ever tried to learn about like what is more efficient, I read ACCA has a book called Manual H. It's their heat pump book. And you start learning about economic balance point and thermal balance point. And to try to calculate economic balance point, there's a lot that goes into it, especially if you want to do it right, right? So, once you learn it, it's not terrible. It's just going down the path of figuring out how to do it.
Right. Very good. I know in central Kentucky I guess it was about a month ago, we had some really cold weather going out. And, it's rare for us to get below zero, but, one morning we got up and it was 7 below. And a lot of well-meaning local HVAC companies were handing out some, what I feel is very bad advice. They were telling customers to shut off their heat pumps and turn on pure electric heat. What's your all's take on that? Is that good advice, or is that advice that we should just not even talk about?
That's a trigger for me.
Good.
There's some companies in Texas that are very mad at me because I was literally calling them saying, hey, you have to stop with this bad information. So in Texas, we went through the storm of the century where it came through and we lost electrical power. And these companies were telling people, turn it to emergency heat. Well, we're already having these blackouts all across the state. And now people are turning it to perfectly running heat pumps. They're turning them to emergency heat just because somebody said to. Now you're using way more energy. And then we started having complete blackouts all across the country or across the state. And it was because of bad information. They didn't know any better. I understand they get overwhelmed with service calls coming in. Instead of telling those specific customers what to do, and usually it's because they didn't set up defrost correctly, so they just had them turn everything emergency heat. Well, then the blackouts got worse and the problem got worse. So it's amazing how one little bit of bad information can be life or death when you apply it to the whole system. Because we're in a world together, and it's I'll be on the Pearl will vouch for it. I'll be on the phone. I was just like literally calling them, hey guys, you got to take this off. This is going to cause a bigger problem. And a lot of it's just people don't know. They thought that heat pumps don't work below 30 degrees. And I talked to them. I was like, have you ever worked in a walk-in cooler or walk-in freezer in the middle of summer? Oh, yeah. Well, then you can appreciate that it happens. Most of them had their defrost time set to max out. Oh, we're trying to save the customer money. Well, let's talk to you about how defrost works. It's not staying in defrost this whole entire time. We got technology that takes it out of defrost if there's no frost. Like it's only for a short period of time. They didn't understand that. They thought defrost is using a lot of electricity, and I tell people, well, just like a walk-in cooler, if you don't have enough defrost cycles, you're using more electricity and so I start comparing the things that they know. And some people listened, and some of them just, blocked me and shut me down. But I was trying everything I could to try to save, ultimately, the grid and the customers from these outrageous electric bills, because the price of electricity jumped up too. So it's a simple thing like, hey, let's understand heat pumps. Let's understand these defrost. And if you don't want to work with heat pumps, that's your business model, then make that clear up front. Don't work on heat pumps. Don't service heat pumps. Leave it to the professionals that do. And I know other people that don't want to work with gas furnaces. That's fine. Don't do it. If you're going to work in gas furnaces, have the education and knowledge to do it. If you're going to work with heat pumps, have the knowledge and education to do that. And it takes training. It takes practice doing it. Everything we do in this trade is complicated. That's why I call it skilled trades. So we need to be addressing that. So if somebody doesn't like heat pumps, cool. Just stay out of that side of the field. If you're going to work on it, learn about it.
Right. And you mentioned a very interesting point, Ty, and that's, I think, something our industry tends to gloss over, is that when those temperatures were dropping, the output capacity of the heat pump drops as well. And many times it's because the customer isn't getting those BTUs into the conditioned space because we think that the heat pump is the system. And that couldn't be farther from the truth. Right. The heat pump is a part of the system. It's a component. And unless we get past that and we start looking at, as you guys mentioned, airflow and the ducts, there's going to be some serious problems that we haven't even been able to predict what the trickle-down effect is going to be. So it's crazy. So with that, there's a certain amount of skills that are needed for a heat pump. What are you guys seeing as being some of the most important skills that someone who may be coming into the industry would need?
I just want to jump right into this, and I would say, like, more important than anything, and I've had this argument so many times with so many different people, like, if you're installing a heat pump, you need to learn the best practices. Like, that is huge. And I think that a lot of people don't consider what happens, but, like, all right, so if you don't pull a good vacuum, if you're not removing your cores, and you're not using big 3/4-inch hoses when you're pulling a vacuum, and you're not dehydrating the system, you have moisture in that system. And what happens if you're trying to run a heat pump when it is negative 10 degrees outside with moisture in the system, right? What happens to that moisture? So, best practice.
Yes, so airflow, which is the big one we've talked about, but also when you buy that piece of equipment, there's this package in there, and it's not knee pads. It's the service manual. And RTF film, read the fabulous manual, because from one manufacturer to another, there will be difference in installation practices. Just because somebody told you, was a well-meaning person, told you to do something one way however many years ago, doesn't mean it's still that way now. And actually, a lot of times you find that it wasn't that way back then either. So a lot of shortcuts and rules of thumbs and wives' tales that we've been told do not work. They really didn't work back then, and now that our equipment's getting more technology and being able to do more things, that precision comes with it. Just like back in my day, we had carburetors. We could tune a carburetor with a screwdriver. You could put bad gas in, it would work fine. You put bad gas in a car today with fuel injection, it's more precision. It doesn't work well.
And to that point, there's a lot of people that are saying, equipment's not like it used to be. And what I'm hearing you say is you're right, it's not. It's more precise than it ever has been, and there's a less tolerance for error than there ever has been. Now, you guys mentioned the engineering pieces of this. Ben and Adam, you mentioned the equipment capacities and stuff.
Yeah.
How, when we start looking at this, you're saying that some heat pumps are better than others. You guys care to expand on that a little bit? What makes one heat pump better than another's? And this isn't to necessarily point fingers at manufacturers and saying, your equipment is better than this one, but I mean, just the details of what that equipment can do.
Yeah, so I mean, I wouldn't necessarily say it's one piece of equipment that's better than another, hands down. It's more like there's different pieces of equipment that fit an application properly, and an example might be like choosing a cold climate heat pump if you're in a cold climate, for example,
Right.
or sometimes even choosing a cold climate heat pump so that you can kind of balance the heating capacity with the cooling capacity a little better and maybe eliminate the need for heat strips altogether. But you don't really kind of get to that level of sophistication in finding the best piece of equipment unless you open that manual or, open that PDF or whatever and look at the data and actually see that, oh, hey, look, maybe even it's the same model family, but one's a 2-ton and one's a 3-ton, and they just have drastically different, performance curves. That kind of stuff happens with heat pumps, and you really have to just it's about the best piece of equipment for the application, not necessarily like, oh, this manufacturer is better than another or this model is better than another.
Okay, so it's not a matter of making the square peg fit in the round hole. It's
Right.
Yeah, I think it's so misleading that we call them tons in the first place. So if somebody says, "Oh, I need a 3-ton system," they just think, "Oh, I'll just go pick this brand and put a 3-ton in," and it's vastly different. It's like if I need a 3/4-ton pickup. Well, what if I got a V6 versus a diesel versus this versus that? Like, it's still a 3/4-ton, but it means completely different things. So calling something a 3-ton piece of equipment is very misleading. And so many technicians and business owners, they just think, oh, I'm just going to put a 3-ton in. And they've never even looked at a performance data. They've never been introduced to that. Once you see the numbers, you're like, wow, these systems vary greatly. And that 3-ton is just a label on there. It doesn't mean it's a 3-ton.
Yeah, and it's we talked a lot about heating, but if you start looking at cooling, right, and then you look at like SEER ratings, so you have higher SEER units, you have less dehumidification most of the time. Sometimes you'll have some type of dry mode or something else like that you could set up. But let's say we're down in Florida, we're in Orlando right now. I would say it's most of the time pretty humid, right, or in Louisiana, something like that. So you get a really high-end, high-efficiency piece of equipment that does really well with Sensible, but then it doesn't do so well with latent. And then you could start having moisture problems, mold damage, all kinds of stuff like that if you're not paying attention and selecting the right piece of equipment for the proper application.
Right. And you and Chris Hughes gave a great presentation at Brian Orr's symposium just last week that the HVAC school puts on. And you guys talked about a massive problem that's coming out with inverter-based heat pumps, and that's just finding the information. Sometimes it's behind a firewall, and you can't find this stuff. So, I mean, if we're going to solve this problem, the information's got to get out there. I thought that was an incredible point that you guys made.
Thank you. I appreciate it. Yeah, like it's funny because we've experienced it. That's kind of why we went down that path to try to find the information. We were working on it like on and off for 6 months, trying to gather as much commissioning and charging information on all these different brands. It's very difficult to find unless you're a dealer for that particular brand.
Yeah, so what I'm hearing is manufacturers, if you're listening to this, help us help you.
Yeah, but also, I mean, I think there's a point in there, for dealers or contractors that sell a specific brand, know your line. Call your manufacturer rep, your distributor rep, and get that data,
Right.
And know it inside and out, so that you can get your customers the right piece of equipment, for the brand you're selling.
Yeah, you guys, where we're talking about inverter-based equipment, I've seen a lot of guys just say that takes the sizing piece out of it. What are your thoughts on that? Because you can get a 5-ton and ramp it down if you have to. What do you guys think about that?
So, I mean, I think inverters are great, and the reason that they're great is that they can ramp down to be able to match the load. Well, if you oversize an inverter piece of equipment and you're running it, at 40% of its capacity, all of a sudden you've lost that ability for it to ramp down at all, and it's just going to start shutting off and cycling on and off, and you're not going to get that savings or performance out of it that you thought you were going to. Also, a lot of them, at those lower capacities, you can't ramp the fan down as much as you can ramp the compressor down. So at those lower capacities, if you're running at those all the time, you're killing your dehumidification capability.
So I have something that I say to that point, just very short and sweet, and then I'll let Ty go. But an oversized inverter is the most expensive single-stage machine that you could buy.
That's right. That was what I was exactly going to say right there.
Sorry.
No, it was perfect. It's just, you only have such a range. And I think the salespeople for the equipment do a really good job at, it's an inverter. It'll just automatically, adjust. And, I mean, they want to sell equipment. They want to sell their brand. So I get that. But then you have contractors that haven't gone that extra step. They're trying to keep their business afloat. I get that too. And they're just taking them for their word. Oh, it'll just slow down. Well, there's only so much it'll slow down. If I put a big block 460 driving around, I can only slow down so much sitting there idling. It's still using a lot more fuel than a smaller vehicle. So the inverter only has a range that it can work in. And the really thing that people overlook is when it does slow down, what's happening to the latent heat? What's happening to the dehumidification capacity? Most of the manufacturers aren't publishing that, and I'm maybe just being a conspiracy thing, but I don't think they want that information going out, because then people will see at those shoulder season, when you need it to ramp down, you're not dehumidifying. And I hear this a lot. People say, put this inverter in. And then a customer will call me, or a company will call me and say, hey, Ty, I need your help. I need you to do your psychometric magic. And I go in there and find out that the system is, it's still running, but it's not dehumidifying. And that's what we need the most on. So they're spending all this money, and it's just simply lack of knowledge. If they knew how to do this, they knew what was happening, they sized the system correctly, they would solve the customer complaint issues. Customers would be happier and healthier, and so would the building as well. But it's a big step, because we're trying to manage a business, manage all this technology, and I think that's where NCI really comes in. I mean, you guys are really putting out there the skills that you need. David, I've been learning from you forever. And I've been watching you go through some of these high-performance jobs that would scare me. Like, if I was a contractor, I'd be scared to do the things that you've done, and you made it happen. So there's people out there that's doing this. People go back to what they see. Well, they can see that you've done this. You're not just, it's not an idea. You're doing this. You've been doing this. You guys have all the numbers to back it up. So it comes back to getting that education. Go to the experts. If you don't know, that's okay. There's a lot of things I don't know. I go to the experts and I learn more stuff. So get educated. Start taking classes. And it's overwhelming at first. I'm still learning new stuff. It still gets overwhelming, but you have to start somewhere, get that knowledge.
Excellent. You guys mentioned the change in some of the older heat pumps versus the newer ones. Where older ones, I mean, they may dehumidify just fine, but the newer heat pumps won't. So what are some options that a contractor could consider if they find out that there is a big difference? And during those shoulder seasons, as you mentioned, Ty, we do need to do something different. What are some options?
I mean, if you're going to start looking at indoor air quality as well, there's certain areas in the country, and I'm not just singling them out, but like my brother is from Louisiana. I kind of think almost everyone should have a whole house dehumidifier in Louisiana, just because of it will be 70 degrees outside at 75% relative humidity, and you can't run your air conditioner at that time, right? Yep. You can't cool, you can't dehumidify. So what do? He called me and he said, what should I do? And I said, bake cookies. I think I stole that from Gary Nelson. But
So, because the thermostat's all driven off sensible heat.
Right.
Yeah. And then it's magnified when you talk about duct leakage. So you're bringing more of that outside air in. So you run the system to humidify, and then you're causing a greater problem. So it goes back to also the house as a system. Duct leakage is so overlooked. I mean, it's just amazing. Actually, Michael House just walked in. I learned so much from him because he's in a climate that's different, so much different from mine, and where they put the insulation and the vapor barriers. And I've really challenged me to think in a different way because from my climate, what I'm used to.
Right. Yeah, Michael's an hour and a half north of me, and we get the worst of both worlds. Because we get the coldest winters and we get the humid summers. So you have to handle buildings a little bit differently based on where you're at. And that brings me to an interesting point you mentioned about the building too, Ty, that with those ducts and everything being connected, what I'm hearing, correct me if I'm wrong, what I'm hearing you say is if those ducts aren't right and that inverter heat pump that you just put in is running nonstop, it could actually make, regardless of the equipment capacity, could make a dehumidification problem worse.
Absolutely. I see it all the time, constantly. You can buy the best piece of equipment, but if you put it in a bad duct system in a leaking house, then you've just unlocked a new level of problems.
Yeah. Adam, I know in your session you're going to talk about a term called thermal dissonance. You care to talk about that a little bit? What that war is about?
Yeah, that was actually, we talked about that last year. That was my first presentation ever. I was pretty nervous giving that thing, right? But like, just kind of thinking about what, you want your HVAC system and your house to be in alignment. You want everything to kind of work together, because if one of them's way out of whack, you're going to figure that out very quickly. It's not going to work, especially with a heat pump. Now I've lost my train of thought. You said something I wanted to make a comment on, but I lost it. I'm sorry.
That's all right. Ben, you mentioned the load calculation being one of the first steps. And what's interesting is the load calculation has nothing to do with HVAC. It's 100% building science.
That's right. Yeah, load calculation is all about figuring out what the building needs. And then you got to go the extra step in system selection, with the manual S, of figuring out what the system can actually deliver. And you got to match those two up, and they have to be matched up well in a single piece of equipment, or you have to, offset one thing or another, like add some dehumidification, or you might have to, add some heat with some other source or something like that. But you got to look at those numbers and figure them out, and you got to take a deep dive on every house.
Yeah, and it used to be, as you guys said, we could get away from that. It came back to you, didn't it?
It did. Ty mentioned, and you just brought it up too, dehumidification and duct leakage, and how duct leakage can impact the humidity levels in the house, right? It's not just bringing in humid air. You could live in a dry climate, and you could be drying out the house too with duct leakage, right? And you could have a lot of negative impact on the home if you don't have the correct amount of airflow. So dry climates, you want to usually have more airflow, CFM per ton. Very humid climates, you want less airflow, and you're trying to overcome that. So if you don't have the airflow set properly, and if you don't have, your duct leakage under control, big issues.
Yeah. Also, with dehumidification, I was going to mention that it's also important to know the different capabilities that your equipment can do to help deal with that. So, like a lot of them will have a dehumidification mode or a dry mode, or some manufacturers actually call that the wet mode. But, knowing these different things, these different control techniques that you can use within that piece of equipment to help you manage humidity, can help.
And not just knowing what they are. Does it have an option, but what does it do?
Yes,
right?
Exactly.
Because some of them will overcool to dehumidify, and others will ramp the compressor and slow down the fan motor. What's the method of dehumidification that this equipment provides?
And as you said, some of this is just, it's hidden. It's the secret sauce that nobody's letting out. So the technician and the designer and the installers have no idea what it's even doing in the first place.
Yep.
So you guys mentioned the building. I want to go back to that for a second, because I think so many times in our industry, we don't think the building, and many times it may not be our responsibility, but it is to understand it, because that's the environment that we've got to condition. I think if we change just a 90-degree viewpoint from how we look at a building to it is actually, as you guys have said, part of the HVAC system. It's the extension of the traditional HVAC system, and the building is part of the duct system. And that built inside of the duct system it's a BTU container. And if we don't account for that with a heat pump, we're going to have some issues. So if there's, for those that are listening, they're thinking, how do I even get involved in that? I want to get into heat pumps, but now you guys are mentioning all this other stuff and you're scaring me to death. What are some first steps that someone can take?
Well, I say you need to take a class. I love learning about this, and the more that I learn, the more I realize I still don't know. And it's overwhelming when you start looking at the building science, or I don't like even using that, because there's just understanding the house itself and how it interacts with people. So I say find a class. Like NCI has really great classes that put these together in a way that helps benefit you. It helps bridge the bridge from HVAC over to the house as a system, because you can get lost in all the information. You can be chasing a rabbit hole, solving a detail that doesn't really matter because you have a bigger elephant in the room you got to look at. So what I love about NCI is they take it from a business aspect of, hey, let's solve these problems in a methodical way that will lead you to the answers. And I think that's incredible. Ultimately, I just want people learning. Like, you have to keep learning and challenging yourself. Even if you hate heat pumps and love gas furnace, I guarantee you there's a lot of stuff you don't know about gas, because I'm still learning basic things that I feel like I should have known. So you have to keep learning, keep on. If you think you know something, and revisit it. And you're not going to get it from one class. Take another class, listen from different people. If you're struggling with one presentation, take it from another presentation. You have to just keep looking at it and keep trying. And then as you learn, you get more excited. Like, it's frustrating, it's overwhelming. It's like, wow, I can solve this problem. Then you're helping a customer. You're doing something else that your competition can't. And instead of trying to bid on price, now you're bidding on, hey, I can solve problems that other people can't.
Yeah. Yep. I would say that definitely take a class, right? The biggest thing is understanding how a heat pump works. Like, what are the basics? And a book that just came out recently, Craig Migliaccio, AC Service Tech, he has an amazing book that kind of goes over the heat pump circuit, the refrigerant circuit, how everything works. You know, we talk about providing something that's warmer than or colder than, different temperatures, and how heat absorbs. So understanding the refrigeration cycle on a heat pump, that's number one. And then number two, maybe coming and taking an NCI class and understand, like, how do we provide the performance? How do we get the equipment to perform the way it really should? Talking about refrigerant charge and airflow, right? And then maybe the next step, if you're going to start installing them and designing them, maybe look at taking an ACA class. There's an online, ACA provides an ACA online class to start dabbling your toe in load calculations and understanding how you actually figure it out. And it's not magical. There's actually math involved, right?
So I'm hearing you guys say putting a plan together is very important. And then to continue learning. Don't just do it once. The late founder of NCI, Rob Falk, used to have the saying, and it was, we leak information.
Yeah. That's kind of what I was going to say is, take some classes, read some books to learn the fundamentals that you need to know, but also know that you can never be done learning if you want to continue to be good in the industry, because the equipment's always changing, houses are changing, how houses are built. There's always these new things that are coming up, and the most important thing is to learn how to learn and get a thirst for that knowledge, and you're going to keep going your whole career if you want to be successful.
Excellent advice. As we wrap up, if someone's listening to this, and you guys have provided so many great examples, if someone's listening to this and they're just getting started with heat pumps, what would be your advice to them? What would be step number one? Ty, we'll start with you and go around.
The refrigeration cycle. The more ways you can understand it, the better. I find that most people that struggle with heat pumps, ultimately, and I don't mean to offend anybody, but they don't understand the refrigeration cycle. The latent heat of refrigerant changing state, what's really happening in the evaporator, what's really happening in the condenser. Once you understand that, then it's just a matter of, hey, we got a compressor that's putting out hot gas. We're either going to send that hot gas inside the house or we're going to send that hot gas outside the house. And then it just takes the suction side and connects it back to the compressor. And once you understand the refrigeration cycle of heat pumps, pretty easy. And just like refrigeration, we add controls and we can make it do really awesome things, because all we're ultimately doing is moving heat from one place to another. Whether it's refrigeration doing it just one way, air conditioning doing it just one way, or heat pump, we can send it either way we want. That's, one of the hardest things. And then, of course, airflow. I thought I was really good with airflow. Once upon a time, I had the least issues with airflow, and then I learned this thing called Manual D, and then I had to relearn it again. And I'm like, yes, now I'm a rock star in it. And then I learned about testing airflow, and I started testing. I'm like, oh man, now I got to make more changes and adapt again. And I'm still learning like little tricks and stuff. So refrigeration cycle, airflow, and then following the installation manual.
Nice. Man.
Yeah, I would agree with those things, but I guess just to, throw something different in there, I would say really try to understand, the brand or brands of equipment that you sell. So, memorize the manuals for those, but also read the new ones when they come out, because there's different stuff. But know what you sell. I'd say that's the other thing I could add to the big ones there.
Know the equipment. Adam, bring us home.
I would say just kind of if you've never done a heat pump before, and put together a plan. Don't jump right into it. If a customer calls in, I want a heat pump, I wouldn't just go for it and try to, make it work. You don't want the square peg in the round hole, right? You come up with a plan and start to follow it. You need a path to this, right? It's not something, Rome wasn't built in a day.
All right. Thanks, you guys, for listening. This is David Richardson with NCI again, joined by Ty Branaman, Ben Lipscomb, and Adam Mufich. Thanks, you guys, for coming on.
Thanks, David.
Thank you.